Okay, so like I said, this is technically 12.3b, but we skipped 12.3a. We're just not covering it anymore. We don't need to. So recursive rules. Now let me stop for a minute and let's talk about all the rules that we have. We started off with arithmetic sequences. Do you remember the rule for the arithmetic sequences? F of n equals f of 1 less d parentheses n minus 1. I'm a little frightened right now. Because nobody was saying anything there. All right, I'll try and be more clear with my directions then. All right, after we did arithmetic sequences, we learned arithmetic sum. And that was S of n equals, how did that formula go? N times the first term plus the last term all over 2. Okay. Then we moved on to geometric. And I should specify this is explicit, because today we're doing the opposite of explicit. So this one was f of n equals, do you remember the formula for geometric explicit formula? F of 1 times r to the n minus 1. Then we had geometric sum. This was the ugly one. Anybody know how this one starts? F of 1 times 1 minus r to the n all over 1 minus r. Yes. I don't know. But if you have a cheat sheet, it would just be like this. It wouldn't have any of the names on them. Okay, it might have the formulas, but it wouldn't have any names. But I don't know, we haven't decided that yet. So let's see. Today, we're going to learn 2 more formulas, and I'll save those just for suspense sake right there. Let's talk about what this whole thing is about recursive. Okay, recursive tends to be the first way you think. Okay, if I give you, I'm going to start off with 2 examples that are not arithmetic or geometric. Okay, so here's our first one. You ready? And I just want you to look at it for a minute and see if you could figure out what the next number would be. Following the pattern on there, what would the next term be? 21? Okay. Anybody agree, disagree? There's a pattern going on there. It's not arithmetic, it's not geometric, but there is a pattern going on there. I have a 26. Anybody agree, disagree? Okay. 21. 21. Oh, we have a submit there. Okay, so one thing that was interesting about this one, when you were doing this, I saw you going like this. That's very recursive. I like that. How did you come up with 21? Because you were the first one that said 21.
We add the first two and then it's like the third one. And then it's like
So 1 plus 1 equals 2. 1 plus 2 equals 3. 2 plus 3 equals 5. 3 plus 5 equals 8. So you're adding two terms to get the next term. Does that make sense? So the next one would be 8 plus 13, which is 21, and you could keep going on, forever and ever and ever. Should put ... there. This is actually a famous sequence named after a mathematician. Fibonacci. It's the Fibonacci sequence. Okay. And let me ask you a question. Would it be easy or hard to find the 50th term on that list? Why? Maybe not hard, maybe pain in the butt? Why? Why? Because I don't have an explicit formula to just plug in 52. In order to get the 50th term, I need the 49th and the 48th to be able to add them together. Well, in order to get the 49th, I need the 48th and the 47th. So then to get the do you see how I'm just going to kind of need all the numbers between here and there in order to get there? Yeah. That's what recursive is. It's relying on terms before to get the next term. Okay? So let me translate this to you. I said this one isn't arithmetic or geometric. It's not a formula you would need to know. But this is what the rule that we just explained would look like mathematically. You ready? So to find a term, to find any term, you add two things, right? So I'm going to put a plus sign right there. We add two things. We add the term before, right? To get 21, we add the term before plus the term 2 before. Does that make sense to you? To get any term, you add the term before plus the term 2 before. Here's how you notate that. The term before looks like that mathematically. F of n minus 1. That means the term before f of n. What do you think the term 2 before is going to look like? Yep. Now, recursive formula, you have to add a couple things. Like that. This whole thing is the formula. And that's just my explanation, obviously. That whole thing is the formula. Now, what's this part at the end? What did I just give you? I gave you the first term and the second term, didn't I? I'll explain that a little bit more in a bit. But recursive formulas are always going to have something at the end here. Okay? Let's try one more that's not arithmetic or geometric. I'm going to write the sequence. I want you to try to identify what the next number would be. Okay? You ready? Can you figure out what goes in the blank? You might need your calculator. No, not 1,500. They're hiding. Here, you can use mine. We'll clear the answer first.
1,240.
Okay. $1,440 is the next one. Okay. Now that we have the next term, can you describe what's going on? How did you get that next term?
Alright, so by multiply and multiple, multiply 2 times 2, that makes 4, multiply 4 times 3, that makes 12, or 10, 12 times 4 makes 48, 48 times 5 makes 240, and 240 times 6 or 40.
So you're saying here you did times 2, times 3, times 4. Is that correct?
Yes.
Times 5 and then times 6? Okay. That's one way you can explain it. Absolutely. Okay. I thought about it slightly different. Okay. I thought about when you're looking at recursive rules, a lot of times the first term isn't super helpful. It's more helpful to start like in here to look for your pattern. I noticed that 48 was 12 times 4. This one is 4 times 3. So it's a similar idea. That one's not going to help me very much. This one is 48 times 5. So in each one of these, do you see it's taking the term before it and multiplying it by something? Do you see that? So each one is taking the term before and multiplying it by something. What is it multiplying by? What are these numbers? In other words, to get 12, I'm multiplying by 3. To get 4, I'm multiplying by 4. How are those numbers related to those terms? What term is this? What term is it? First, second, third, fourth, fifth. Do you see anything interesting there? To get the fifth term, you multiply by 5. To get the fourth term, you're multiplying by 4. So to get the 10th term, you'd multiply by 10. Does that make sense? So you are multiplying by the number of the term you are looking for. So in other words, to get the 15th term, you would take the 14th term and multiply it by 15. And then you would put your little 4 f of 1 equals 2. That's your whole rule. Now, you are not going to be required to look at things that are not arithmetic and geometric and come up with those rules. Okay? That was kind of just to introduce you to the notation of the term before and that kind of thing. Now, the reason why we have to include the first term is if I covered that up and I just gave you this and I said write down the first 4 terms. How do I write down the first term? If I didn't give you this, how do I write down the first term? Because to find the first term, I take the term before, wait, that doesn't make sense. What's the term before the first term? That doesn't make sense. If I wanted the third term, I need to take I don't have a starting place. Do you see that? So they have to give me one of these. So I don't start with the first term. I would start with the second term because they already gave me the first one. So to find the second term, I take the first term and multiply it by 2. So they have to give me a starting place. So whenever we're writing these recursive rules, we always have to include f of 1 at the end. Why do you think this one had 2 terms given? F of 1 and f of 2. What was that? Louder. Louder. You might have been onto something. You never know. You might have been onto something. Because you need 2 terms before it to add together. So you can't start off with the first or the second term. The earliest you could start on your sequence would be the third term because you need 2 terms prior to there. So you have to give 2 terms. All of ours, we're only going to need to give 1. Just know that you're going to need to get in that habit. Okay? So, let's look at this. What do I have here? What do I have? What kind of sequence is that? Uh-huh. And I heard plus 10, that means our D value is 10. When you say plus 10, you are thinking recursively. You are thinking, I have to take the term and add 10, meaning I can't get the next one until I know the one before. So plus 10 is exactly where I want you to go with this. So to find our formula, we say f of n equals, if I want the 15th term, how am I going to find it? I'm going to add 10 to the what? 14th term, right? If I want to find 33, or the 4th term, I take 10 and add it to the 3rd term. So f of n is equal to the term before plus what? 10. To find any term, you take the term before it and you add 10 to it. And then I put the for what? F of 1 equals 3. That's my full rule right there, my full formula. Arithmetic's pretty easy. So let me come over to my formula list. Arithmetic recursive. F of n is equal to f of n minus 1 plus d. And of course you have to do the for f of 1 equals whatever. Does that kind of make sense? Pretty simple formula. All you really need is d in order to write it. However, you do need to include the first term there. Okay? Oops. What do I have there? If I just did arithmetic, hopefully your logic says that that should be geometric. It is geometric. Can you find R for me? Okay. So in other words, if I took 40 over 16, I can divide both of those by 8, and I get 5 over 2. Yeah? Okay. So my R value is 5 over 2, or 2.5. Okay? So, how do you get the next term? How would you get the term after 625? You would take 625 and do what? Multiply by 2.5, or 5 halves. So, in other words, I could say that to find a term, you take the term before it and multiply it by 5 halves. For f of 1 equals 16. By the way, sometimes it might not say the word for, it might just say comma, f of 1 equals 16, that's fine. So let me come back here for a minute. Geometric recursive. F of n equals f of n minus 1 times r for f of 1 equals whatever. Okay, I still have 2 more examples, but let's look at this list of equations for a minute, or formulas. We have 6 formulas here, and I want to distinguish a few of them for you. Any formula that has a D in it is going to be what kind of formula? If it has a D, it's arithmetic, because arithmetic's the only kind that has a common difference. If there's an R in it, it's automatically geometric. All of our formulas are f of n. All of our sums are S sub n. Yeah? And how do I know if it's an explicit formula or a recursive formula? Does it have f of n minus 1? F of n minus 1 is the way we name the term before. Don't get confused with that, because that's not naming the term before. F of n minus 1 is naming the one before. Okay? So those are the formulas you need to be familiar with. You need to know how to use. Okay? All right, let me try this one. Your instructions here. I'm going to give you a rule, and you need to give me the first 4 terms in that sequence. Now, stopping right there for a minute, what kind of sequence is this going to be? Arithmetic, because we are adding a d value. Now, do you see how I don't have a starting place? So if I were to ask, if I asked you, which was what we're doing, for the first 4 terms, right there, how do I know what goes in the first blank? That's why we have to give you this in a recursive formula. Because otherwise, what do you put in that first blank? 0, 10, negative 100? You have no idea. So when they give me the first term, that goes in the first blank. And then what do I do to find the second term? I take the term before it, which is 3, and I add 0.2. What does that give me? And then I add another 0.2. And another 0.2. And that's what the first 4 terms looks like. Does that make sense? Now, the trick about these ones, especially come test time, is if you get the first term wrong, the rest of them are wrong too. If you get the second one, or the second term wrong, the third and fourth are guaranteed to be wrong. There's no way around that when we're doing recursive stuff like that. Okay? All right, one more. I'm going to give you the rule. And I want you to list the first 4 terms. What kind of rule is this one? Geometric. Oops. Now, only when we give you a rule, or when the book gives you a rule, will they give you something crazy like this. The 0th term is 3. That doesn't make sense, does it? I don't know why they do it, but what that means is if this term is 3 and they're calling it the 0th term, then you have the first term, second term, third term, fourth term all come after that one. Does that make sense? So you have to give me the next 4 terms, as opposed to including that in the 4 terms. That kind of makes sense? Good answer. Okay, so what am I going to do here? To find the next term, I'm going to take this one and I'm going to do what? Multiply it by 0.2. What's 3 times 0.2? And to find the next term, I'm going to take 0.6 and multiply it by 0.2, and that gives me what? And then 0.024 and 0.0048. Questions? All right, your homework has posted. Happy studying.